This episode of the LabVIEW Experiment is brought to you by Zaya Solutions.
If people were really, really real with ourselves, would we be trying to come up with the next best architecture, or would we be trying to come up with the thing that allows us to find flaws quickly and try to address them?
Welcome to the LabVIEW Experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. All right, so I am here with Norm from NI. Yeah, Norm is like he's like Madonna. It's like you just say Norm and everybody knows who you're talking about.
Norm, well, I changed my title. Usually when I put it on there, I just do Norm with the exclamation point at the end of it now. So
Yeah.
I'm trying to embrace that. I identify as just Norm.
That's cool. Yeah, Norm works for NI. You didn't always work for NI though, right? You were
No, I'm one of the rare birds that came into the ivory towers with some experience underneath the belt. Yeah, I graduated and was doing co-op work ahead of time and graduated, got May 18th, graduated May 19th, first day of work, and worked there up in Milwaukee, and then worked at Texas Instruments for a while.
Yeah, see, I never really knew that until recently. Like, I just always associated you so closely with NI, and then I looked on LinkedIn or something. I was like, wait, you didn't start there?
That's right. Yeah, no, the pathway, it's kind of interesting when I look around NI and I see people that have been there that basically would have been in my start group and kind of saw where they all went in their career. And for me, starting externally and getting that external experience for a while, and then moving up and coming into the company with that external experience already there. And that's always provided a lot of benefit. I still draw off of that opportunity to kind of have that external experience.
So when they dropped you in, did they immediately drop you at the bottom with all the AEs, and did you go through that whole process, or did you bypass that?
That was the funny thing. I came in as a systems engineer, which was at the time, it existed as a role, and it was a pretty high level role. It was one of those esteemed technical roles in the company. So I started there also doing RF, and I was watching all of these people come into the organization, recent college graduates, and they were doing all of these real fun stuff. It was just this whole onboarding program, and it's builds a lot of camaraderie, and they're doing like these happy hours with start group videos where they were doing a lot of creative things. And I was watching it, and I'm like, I didn't get that. I just kind of missed out on that. So I would always, whenever those things would be going on, I'd try to work my way over and just kind of check it out and see those. And funny enough, that's my progression of my career has eventually led me to now being in that department that I would have been in initially had I joined straight out of college.
So you just made up for that by being extra social, is that it?
Kind of, yeah. And also there was, especially with the domain of RF, I ingratiated myself with that department because I had learned RF the hard way. And then that department was being the front line, basically phone support and forum support or whatever else for RF. And I started helping them and teaching them and training them more because at that point there really wasn't a lot of true knowledge. It was a lot of blind leading the blind for a while on a lot of things, or they would escalate up the chain really quickly. And so I took the opportunity to play that mentorship role to basically teach and to train. And eventually I created like a 6-week intensive 6-week program. People would say it was basically, a 2-year college course in 6 weeks that I had created, which the melted brains at the other side of it kind of feels like that for them, I think.
Yes. Is that when you came up with your RF in 5 minutes speech or whatever?
No. Yeah. It was at 0 to RF in 420 seconds.
Okay.
That was actually
CLA Summit or something?
It was a CLA Summit in India, actually. I did a bunch of travel to India for work for NI, and part of that was, I get to be part of one of these CLA Summits, and they were doing 7x7s, and I had seen it done at the North America CLA Summit. I was like, I want to do that. What could I do? And I'm always trying to find those opportunities to get people excited about RF and all that it means, because it's one of these areas that as I've expanded into, even though I'm still involved with LabVIEW and instrumentation and in general, my mind is constantly blown and constantly learning. And I feel like I'm more in tune with how the universe even works by grabbing onto this RF as opposed to saying it's this black magic thing that nobody knows about. So.
Yeah, well, we use the term RF a whole bunch. So what is RF? Just in case anybody's like, what the heck are
No,
they talking about?
actually, that's my first lesson in the class is how to spell RF.
Yeah.
And RF stands for radio frequency as an acronym. But the funny thing is when people ask about, because people constantly are saying, I need to, even just this week, I need to learn RF. I need, especially our sales force is like, hey, I want to do this. I want to be able to showcase these things, but I don't know it enough to do it. And so when people say, teach me RF, what they're really talking about are two separate things. And it bridges this world of wireless and communications. Because there's so much stuff that in the world of test and measurement, we can kind of avoid the nuanced nature of what communication really means. The idea of modulation, it doesn't happen only in the essence of wireless communications. Even if you think cable modems or telephone lines or even a microphone that we're speaking on right now, they're all, we are modulating something, and it's embedding information, and that information is being packaged in some way, and it's being basically transformed for the purpose of, basically my voice is the thoughts in my head, and eventually it's working its way out, and it's being transformed along the way to eventually, stored online. Eventually somebody's going to listen to this, hopefully, and they're going to eventually reconstitute that information back in their brain. It has nothing to do with RF.
Hopefully the same information that you're...
Exactly, what I'm trying to. That's the other thing. So information transfer is so interesting. But that's just there's so many steps in that, and each transform and what are you doing at each stage. But that doesn't have to be RF. But if you're going to work in this world, then I'd say 95 to 98 or more % of the time when you're talking about RF, it's about getting data from point A to point B. Of course, you can do stuff like radar, which is not really transferring data. You're using electromagnetic waves as this medium for extracting information from an environment, or you could use it to blow something up like in electronic warfare or one phase of electronic warfare. But then the other side of RF is indeed this, I get really, really nerding out about it, but it's the fabric of space and time itself. Quite literally, electromagnetic waves are riding on this medium that we don't know what it is. It's just out there. And when you do anything, even if you move physically, your electrons moving through the air, you technically are causing a wave. Actually, I was listening to a podcast recently, it might have been Lex Friedman, and somebody said, like, we have a wavelength. Like, our body's actually, it's extremely small, but we emit these waves, and we're actually affecting the electromagnetic, whatever the fabric of space and time is around us. Now, we see these great grand illustrations of planets, right? You see the warping of space-time itself, and it looks like, the planet is kind of causing this divot in space-time. Of course, that's a two-dimensional portrayal of it. But that thing that planets is warping, whatever that thing is, we're doing it almost any time that we exist. But especially in RF communications or using RF, we are leveraging this thing that we really only know very little about what it is, and we're transferring information and power and all of this stuff to the edge of existence to some degree. I feel like it's James Webb Space Telescope, right? What are we getting from these faint red-shifted planets that we're looking at? It's electromagnetic waves.
Yeah, and we're sending that out too, right?
Yeah, like the Voyager spacecraft, we're finally beyond like our
galaxy or solar system or something.
Yeah, solar system. Yeah,
just outside the solar system.
Exactly.
Okay,
yeah. Like Voyager 1 and 2 just crossed, and we're like, we don't know what's out there, but we can tell that we did something different, and we're still communicating with these things across it's a man-made object that has gone beyond our solar system, and we're still communicating with it. That's why I love RF, and why I've tried to, as much as LabVIEW was the foundation and the bedrock, I have over time supplanted that. I hope not replaced it, but to some degree replaced it with RF, as much of a zealot I am as for LabVIEW. But it's stuff like that, just recognizing that it's never not going to be evergreen, and it's always in terms, RF's never going to go away, and the concepts are, you learn about electromagnetic waves or wave theory, but when you take on how can you take those concepts and apply it to other things that you see in life and just constantly be marveling at the universe? So bit of a segue away from programming.
No, well, I was listening to some podcasts the other day, and they were talking about I forget what they were talking about, but somehow they ended up on the topic of antennas, and they were talking about how like some technologies are never finished, and this guy was talking like the 80s, like, oh yeah, we figured out antennas, we got them down, you know, you can put in the numbers and it designs it and you're done and that's it. And then of course cell phones and everything else came out, and then now apparently antenna design is really crazy radical stuff.
Oh yeah, well even with machine learning especially, you know, the idea of there's people that do RF or high frequency design. There's so much that I watched somebody do it, and you're planning out a river in advance effectively when you're designing a circuit board to some degree, if you're really getting in there with high frequency simulation, because in your mind you see the waves, and of course now we've got this finite element analysis where we can actually see the waves, the electromagnetic waves move, which is very, very interesting. But the idea of, you know, basically throw some criteria at machine learning models and say, give me an antenna that gives these very specific characteristics, and it comes out with some wacky shapes and sizes. Now, to some degree though, the funny thing is, even with some of these crazy designs and Hilbert curves and so many other things, a lot of the times it still kind of gets back to some really simple shapes. Maybe not what comes out of the AIML stuff, but it's that hey, we're going to put some information in. What do we get? How does it actually really compare to that? But the idea of we have the opportunity now to throw these hard questions at machines to see what flips out on the other side and actually give it a shot, and in the realm of antennas too. You know?
Yeah, I think they were talking about like having two machine learning models and just feed what you want into both of them and then compare them and then throw whichever one doesn't perform away and try again. And after a couple hundred rounds, you end up with something that's like super close to what you want.
That's what I've been using Midjourney for my NI Week or my NI Connect presentation. Midjourney is an image AI system where you can just go online, throw in a description of what image you want. And it's been so interesting. I actually used it for Mother's Day book for Martha, my wife, and from our two girls, and basically asked the girls a bunch of questions about what they would want to write Mama, and threw it into ChatGPT and Midjourney, and I got a bunch of images for the book, and it popped it out on the other side. But that idea of the iterative nature of it is also, I think we kind of do that with our code a lot of times, especially when we kind of dive into, you know, we're not artificial intelligence, we're actual intelligence. And so what do? We get influenced by something and we try out a design, right? And sometimes we start from somebody else's or start from something we've already used, or I've done this before where let's just forget what I know for a moment. And let's not try to use any templates that I've already got. What would I do to, knowing what I know, if I could start from scratch and just forcing myself down that path of starting from scratch to see what comes out on the other side, see what kind of value comes out of it. Like you said, throw it at it, see what's valuable, pull out what you like, and possibly throw away what you don't, right? Experimenting.
Yeah, it's very interesting. I read something a while ago, and they were talking about A/B experimenting and stuff with like social media posts and other things. And it was very interesting because instead of trying to figure out what works, you just throw it at the system and you let it decide and like compare the two things, and whichever one works, that you stay with it. And you don't actually, it's weird that you don't actually have to understand the problem, right? Like you just have to throw the data at it and look at the data that comes back and then make a decision based off of that, which I think is very
even
interesting.
Like how it even came to that conclusion. There's a lot of the chess models that happen right now, and you know, in these interviews, you know, I think there was another who's like some grandmaster that was being interviewed on the podcast was, you know, saying what the recommendation out of the learning model says do this, and it makes no sense, and that model can't describe it either. It can't tell you how it got to that conclusion, but it did something bizarre, and sure enough, it got to the other side of it, and it's like, oh wow, I guess that works out. We'll have to see what happens on the other side.
Yeah, I don't know. That could be kind of dangerous. We're using AI for a lot of things where like you want to make sure they get it right. Like sentencing guidelines and other crazy things where you're like, yeah, you know, it might be good to explain why you came up with that.
Yeah.
As opposed to just like, oh, this guy deserves 8 years, this guy deserves 20 years or something.
I wonder what's going to happen with the that concept, especially as we're trying to like put a pause on like ChatGPT 5 or 6 or whichever, and just all these like OpenAI models where we're trying to figure out how can we know when that's happening, or can we ask it without it knowing that we're asking it. So in terms of like, how did you come up with this conclusion, right? We don't know, if we don't know what happens underneath the hood, we don't know if it's trying to fool us.
Yeah.
So that's the danger behind it, because if it gets too smart too fast, then we'll never really have the ability to truly know what's happening underneath the hood. But do we really even know in our own minds, right?
Yeah. Well, the thing I worry about with the AI stuff is if we turn the AI loose and churn out a bunch of content spewed out onto the internet, then the next version of AI is going to train on everything on the internet. So it's going to train on all that shit that got spewed out, right? And so
and it's not flagged or anything else like that, or how's it going to know where it came from? So
yeah, it's interesting. Yeah, and very interesting.
Yeah, it's its own rabbit trail for sure.
Yeah. We'll get
Alice
back
in
on
Wonderland,
track.
really, actually, at that point, right?
Yeah.
Rabbit hole.
Very sure. Yeah, let's get back to some LabVIEW stuff, although that's a very interesting diversion. We had talked earlier about something you called DFD. Why don't you talk a little bit about that? Explain what you mean by that.
Yeah. The DFD, Design for Debug. And it's been this thing that's been brewing in the back of my mind for a while. And as I've looked out on the world about it and tried to search Google and try to see there's not a lot of talk about debugging. There's a lot of people talking about architectures and design for test and different things you can do. And of course, we as a LabVIEW community, we've got our different frameworks and things that we like to use, but so little is mentioned about the thing that we do so much of the time is debugging our code. We spend so much time trying to figure out what went wrong and when. And indeed, we have techniques and tactics that, like, design for test or test-driven design should help prevent a variety of things from possibly making their way out into the wild. But so often we're cursing ourselves, and we're cursing our children or somebody else's children to deal with the fact that we're releasing code that inherently has not been deliberately designed to take into consideration what is it going to take to debug when something goes wrong. And if I look at, and it really is mind-blowing, because if we are going to come up, maybe it's because we would like the new shiny things, we don't like to admit that we're flawed, right? We don't. I mean, if people were really, really real with ourselves, would we be trying to come up with the next best architecture, or would we be trying to come up with the thing that allows us to find flaws quickly and try to address them? And I think this is a discussion that matches on a multi-level perspective, where it doesn't matter if it's a person and a bench and some equipment creating code for themselves, or somebody, the next DQMH of the world, that's, the hot stuff that, people around the world start to use. Whoever you are and whatever you're developing, you have an opportunity to really have a significant impact on people's lives, to make choices that will be something as simple as a log. Right? It's like, how hard would it be for you or to put a log into your program of what's happening? Right? There's some frameworks out there that already have it, but if you're not using somebody else's framework or anything else or toolkit, and you're just starting from a blank block diagram, how much more value would it be in terms of figuring out what went wrong, when maybe you're not the one trying to do the debugging on it and you don't know the guts of it. And that's just a really simple thing, right? You could just dump data to file and just make sure that once it gets past 2 megabytes, you just start trimming it and you cycle it through or something like that, right? That's a really simple way. But then there's also these grand ways of implementing some design for debug, where, hey, now we've got something where it's, hey, I could do like a full replay of my system. Mm-hmm. It's like, well, even beyond simulation, right? You're getting data, you're getting data dumps, you're getting logs to the degree where you could step out of the in situ scenario and say, I'm going to replay it, but at a slower pace so that I can figure out exactly when something went wrong. And really, I think that I was talking to Darren Nattinger, and he was talking about, he saw something where you're characterizing people, that there's like the creators, and then there ends up being the sustainers. I think that was maybe the split.
Maintainers, or
something like that. I can't remember the name. He just told me about it. I forgot. But Darren, he himself and me too, we like to work in this middle zone of debugging. This is a funny thing.
So it's not really maintaining or creating.
Exactly.
Okay.
Exactly. I love playing Wizard. I do, especially with RF. I can look at a spectrum. I can just look at a signal and go, you're probably off-center frequency and you're saturating your front end. And people look at me like, how did you figure that out? Or I'm like, well, I wiggled this knob and it acted this way. So I just know. I feel like Sherlock Holmes, right? A wizard or Sherlock Holmes. And that's a great feeling. Darren even talked about it too. He just lives for that feeling of that mastery wizardry. And that's not a bad thing. I want to make sure people like me and him are filled up, but wouldn't we rather be possibly creating? Imagine if we didn't, to take that thought experiment to the extreme. Imagine that you didn't have to debug. Would he no longer want to program? Well, no, he would probably just find other ways to be extremely creative and other things, and also give value to other people in for what they're doing, because he provides immense value to the people around him. And so as I think about that, it's like, people enjoy debugging, absolutely, but that shouldn't be an imperative towards a person to not do things to make that debugging process. Democratization of debugging? Maybe that's a better way to put it. Don't leave good debugging to the wizards of the world and the Sherlock Holmeses of the world that can just, you have a fleck of, orange on your shoe. Well, that must mean all of these 28 things, right? Some average Joe that's not a detective wouldn't be able to uncover that as well. So can we as developers and designers, and be it a small system or a big system, I've broken it down to two things that are key principles of how we can make the world better. And it's insights and accelerators. Can you give extra insights to the person who's going to be walking up to your system, be it you or someone else, and give them more information than just, it was sunny outside, right? Something trivial that you have to, Sherlock Holmes is using all of these extra things to extract a conclusion from. And so that's the extra insights that we need to ideally give to people. And then on top of that, we can give accelerators. And these accelerators are ways of taking that insight, which still might not give you the actual answer, but accelerating the process towards getting to more insights or finding out what the actual problem is on the other side. Something as simple, I would love to exist in the world, and I created a prototype once that took IO trace. Right? For those of you who don't know that are listening, IO trace is a tool that NI just releases anytime you install anything NI probably. And it will illustrate to you any call to any NI hardware, IV, Skippy calls, or really any Visa, so everything. So you get this massive dump. And when it's turned on. And when people are trying to debug, well, I go and I try to look at, I'll look through this text log of all did. But that doesn't allow me to recreate their scenario. But an accelerator would be something that could digest that log and create, in my case, a LabVIEW VI that has all of the instrument calls, that have all of the values that went into those instrument calls in that very specific order. Right? I wouldn't need their test program, would I? Because right now, how would I recreate whatever their problem was? Well, can you give me your code? And that's a hard thing to do for a variety of different reasons. People like to or don't like to do that. But if I could, just from this text log, recreate just what's going to the instruments, man, I have significantly accelerated the likelihood of me finding out what went wrong when. It might not be guaranteed, but man, it's sped me up. And that's going to get me home to my twins faster at night. And that matters a whole lot, especially when it's not me and it's somebody else.
So you speak about this tool. Is this a tool you've created, or is this a theory? Or
so I suffer from the inventor's complex, or the Da Vinci complex, of once I've figured out that it's possible, then I really stop diving in to drive it to completion. And so I've done it. It goes through, figures out the calls, LabVIEW scripts it into existence, and it went up. And so it's one of these ones that I feel very strongly about its existence, but I want to champion somebody else to make it for me.
Yeah, I was going to say, because as you're describing them, that sounds totally reasonable to do that in LabVIEW. I don't know all the details, but all the pieces are there for sure.
Yeah. And it doesn't even need to be LabVIEW, depending on whoever's domain it is. Yeah. Right? We as LabVIEW developers work with people that do or don't want to do this in general, or we as LabVIEW programmers might even get it. It's like, you're using .NET, that's fine. I'm going to debug in LabVIEW because I've got visualization and algorithms and everything else that I can throw at it.
That's cool. Good stuff. Are you looking to accelerate your projects while ensuring future flexibility? Zaya Solutions' team of LabVIEW architects can help you realize your goals, from initial R&D prototyping through full-scale mission-critical deployments. With their extensive experience in test, automation, and systems integration, Whether it's an actor framework program or a real-time distributed system, they'll get you up and running faster than ever. Learn more and check out their innovative open source utilities for the LabVIEW community at zyahsolutions.com. That is ZYAH solutions.com. That was your presentation title is Design for Debug or Design for Reality. So what is that? What's the reality part of that? Like how?
Yeah, no, it's DFD, Design for Reality, just to be an eye catcher. But the reality that I'm talking about is that we know that debug is gonna be necessary. We need to stop coding for the happy path alone. Mm-hmm. Right? That is so much what we do, and we do it because we're up against time crunches. We don't want to recognize that we're imperfect, and everything works. It's one of the quote that's in the presentation. Everything's bloody well and good until it stops working. That David Corney gave me that quote, and that is when I look at that, I go, what's the program that we made? Why is it hard to debug? Well, it's because we figured it was probably not going to need to debug that much. Right? That's otherwise we would prioritize it. We would make it part of the requirements.
Yeah.
Right. What's our requirement? Get it working. Right. And if we're a good enough programmer, we try to do all the other things that not only make it work, like continuous integration or source code control or indeed test-driven design, all these things that we're trying to learn and grow up as a programming world to do. But on the other side of it, we just leave this, we're far too optimistic.
Yeah.
And I think it blows my mind that the seasoned veterans that are out in the world that know better, we all know better, that we should be actively taking responsibility for making that person's life, basically the effort that they need to do shorter, trying to find the bug.
Yeah.
Because the reality is the bug is like technical debt.
Yeah. And
the harder it is to debug, the higher the interest rate is. Right? The bug's going to exist. We know that there's going to be bugs. But if you make it effectively harder to get to that bug, to figure out where that bug is, why it happened, that's just interest built up on top of it. And the more that we do that, it just makes it worse.
Yeah, I think you're onto something with the thing that people tend to focus on the happy path. Because you notice that a lot, like in terms of readability and maintainability of code too, right? Because they're just trying to get it out the door and they don't really think about the next person that's coming along who has to read it or maintain it, or in this case, debug it.
Yeah, no, absolutely. That readability of the code, I mean, to some degree, that's the essence of SMoRES is almost a prerequisite towards making the design for debug a smooth process. Yeah. And I think that's one of these challenges of if you look at a diagram or somebody's code and it's just this monolith, trying to design for debug once it's a monolith is going to be really, really hard. That's probably part of the reason why people might not want to do it, is because you've just got this monolith of code and like, well, how am I going to debug this without causing it to eat its own tail? But if you do good design, like in terms of SMoRES with scalable, modular, reusable, extensible, and simple, that idea is that, it's some behavior, say it's file IO, is functionally contained to a library or a module or an actor. Well, great. It still exists. Step one in debug for design is make things functionally contained. Right? That you can't. It's because if everything's just one blob of Play-Doh code, trying to isolate things or trying to add things into enable more debugging is going to be much more complicated. So it's not impossible, but it's not as clear, right? To add a logger into a set of code when you have to take all the data from one monolithic loop and try to stream it all into like one VI that might be dangling off to the side.
So one of the things that I've found useful for debugging, this is just my own like small systems that I build, is using the Git history and like taking really small steps and like I release something, right, and it works, and then I release the next version, it doesn't work, and then just going through the log and Git helps me to like narrow it down to like, these are the 5 VIs that changed, so therefore the problem must be in one of these.
Interesting. No, I mean, it makes sense from a practical standpoint, especially if it was working and it
stopped.
Didn't.
Yeah.
And that, I think one of those twists though that I have found over time, especially by working with so much hardware, is that especially or a system of systems and systems of hardware is
it's not the software that changes.
It's not as much the software. Yeah. It's that combination of you moved. Oh my gosh, I ran into this. This is a beautiful illustration of wizardry. I think where it was a system that works here in the States and it works on some systems overseas. And I think theoretically everything's the same. And only because I was able to hack into the code, it was for Bluetooth toolkit. So it's basically doing Bluetooth generation. It was even creating a waveform. And eventually narrowed everything down with the help of a lot of other people. But I got to a part, and it was localization of a decimal point. And in the code, there was a string. And the string has a bunch of numbers, and basically it's select line from string, take that string, turn it into a number. The number populates a cluster to be used downstream, right? And
it's coming up with the wrong number.
It came up with zeros. Yeah, it was 0.45, and it was spitting out zeros, but only on a system in Turkey that happened to have localization, not turned on to decimal point. It was still comma, and it was just one of these things where I was only able to get to it because I knew how to get through all of those layers. There were no accelerators. There were no hints. It happened to be all this tribal knowledge that I had. Total Sherlock Holmes mode. I knew how to get to the code, dive in, and all that. But that was one of those ones where this thing actually even existed all the way back, and there was no versioning even. But when I did get into source code control, that was a beautiful part of getting into that and going, wait a minute, this always existed, and it just happened to be maybe we were dodging a bullet on that.
So interesting, though. So number to string in LabVIEW, it takes into account localization, I guess.
Well, if it's a string that has a decimal point, that's not going to transform when you're on, right? It's the string stays the string no matter where you move.
But the way it interprets it changes depending on, okay.
There's a Boolean on it where it says use localization, and it's default true, and you can set it to false. But if you're not thinking about something like that,
that's a very interesting bug.
But that actually really is actually I'm so great that this came up, because that highlights another idea of this insight. Because one of the insights that you can provide to your users is not, when you do a dump effectively, is not just, and you get a bad result, not just the output and the input, but some of the internal data. Right? There's so much stuff that we do that there's kind of auto modes, if you will, towards, hey, out of these 5 values, and maybe one's like figure out the span by yourself. It'll calculate stuff inside of the guts. And it's that ability to get some of that inside information back up and out that can do a huge job simplifying what happens. Or even it's like, I can't think of the code like where that would have come out, but I know that as I was debugging, what was my mind doing? My mind was slicing and dicing to get down to that point.
Well, like as an electrical engineer, it's like if you design a multi-layer circuit board, right? Not like trapping stuff in the internal traces. Right, like making sure that you have a debug point that you can like probe some internal voltage if it's important.
100%. Well, the funny thing is, when I went searching for design for debug or debug driven design, the only real thing that came out in the world as a repeated hit was JTAG. And if you've done any electrical, circuit work or anything like that, JTAG is the essence of every single pin on a chip has a small little like JTAG cell. And you can address it, and you can get information from it, and you can inject information to it. And it seems like this extremely heavy-handed thing, like, oh my gosh, every pin's going to have this custom thing. But JTAG or boundary scan as a concept is ubiquitous. It's almost on everything nowadays. And so every chip designer will just, I'm going to put JTAG on it because it makes my life so much better. It'd be the functional equivalent of, basically there being a sub VI like off of every terminal on a block diagram that publishes to some global variable when you want it, in terms of being able to like the in the out. It's almost
that would be interesting.
Yeah. I mean, it feels really heavy-handed, but once again, somebody came up with a framework that the industry is standardized on now, and they use it for that and so many other things. It's not necessarily advocating that we do that for every individual VI, but for things like DQMH, even while I was driving in, I was talking to Darren again, and I'm asking, is there an ability to dump information from it? Just a single button, like get the mother cluster information that has all that, and maybe the last 12 commands that have come through. And he's like, no, it doesn't. They don't have it. Nothing's preventing you from making that thing. But maybe I think HumpleSoft has they've got some version of that for theirs.
Do they? Okay, I know they have a Python style debugger thing for LabVIEW that I looked at. That's supposed to be really cool.
No, I don't know.
Yeah, Python has a very interesting logging system built in that works quite well.
Really?
Yeah.
Okay, like you just gonna get every.
Yeah, so there's like a master logger, and you can set up a logger for each module if you want, and then you can set different loggers to like log to database or log to file, and you can set different levels. So there's like 4 or 5 levels, and depending on what level you select, then that's what gets logged.
That was
So it's
actually
interesting. Yeah.
not Python, but it's a tool called Synergy by a company called Seamless. They do single keyboard and mouse, and basically wherever your cursor is, it'll automatically transfer to a different computer, and you can start. It's like kind of like an automatic KVM,
Okay.
but it's based off of where your mouse goes on the screen. It's fantastic, but I was having problems with it, and I marveled at how wonderful it was to debug the software because they had basically an enumeration that you can change the debug level on. It's like info error or error info, whatever.
Yeah, critical warning.
Exactly.
Whatever.
And when I'm like, okay, everything's eating the pillow here. Hold on a moment. Let me just turn it on.
It's the lowest level debug, yeah.
Exactly. And it's like, oh, I solved my own problem. And I didn't think of their software as being buggy.
Yeah.
I was like, oh, well, I was able to figure it out fast enough. That's okay. And that really just spurred me down this entire thought train of how can we provide that kind of seamless debugging experience where we can give that kind of information, because I like that so much from that. The world needs to start thinking about that in general and doing it more. It's great to hear that Python has something like that.
Well, so what they're trying to prevent in Python is when you're debugging something, you add all these print statements everywhere, right? Print.
Yeah.
And then you have to either delete them or comment them out, but then what if you want them back later and all this stuff? So you just put it in as like debug, and then you set the flag to normally not report that stuff. And if you want it, you can get it.
Oh, that's
but
great.
one thing I see people do in LabVIEW, I don't know, maybe you've seen this. Do you see VIs that have like string controls, particularly like big string controls on the front panel that aren't connected to anything, that are just there to like debug some internal value? Do you see that?
I haven't seen that with string. I've seen that with graphs.
Yeah,
that's
graphs.
not uncommon.
Yeah, it's got it's collecting data and it's spitting it out, but you got the graph in the middle so you can take a look at it.
Exactly. And I've seen it where, you Active Framework does something with this where they have, AF debug equals true.
Yeah.
You flip that sucker on and you get, all the information
stuff,
goes
yeah.
to dead. And that's great. That is 100% a design for debug, consideration, right? They made that possible. They streamlined that process. It doesn't solve your problem for you, but wow, when everything goes haywire and Active Framework's just this amorphous blob of actors running in the ether.
Yeah.
Even DQMH to some degree, but DQMH at least has the testers and you can blast open a panel.
A little bit easier,
it's just part of the framework. No matter what, like I said, no matter what we're making, we have the ability to emulate that, even to a lesser degree, right? If you like something, if you see something, man, just go ahead and do it. You'll thank yourself later. And if somebody you're going to be really making a significant impact on somebody else's life too, very likely in the future, even if, you don't get credit for it, but just know that you're doing the right thing.
Yeah. So what are the most effective debug tools in LabVIEW, or like designed for debug things? Or is this getting into your presentation too much?
No. I would say the most effective tool is the loose nut between the keyboard and seat.
Okay.
That's the developer. That's the joke with that one is the I would say data is such a first-class citizen. Type preservation is, and trying to take advantage of the fact that it's very easy to start doing things in parallel. In LabVIEW, to the degree of, hey, I just want an interesting illustration of this, and the kind of that level 1 implementation is, if you've got data flying through and you don't know like when a reentrant VI that's just being spawned in the background is running, right? That's a pretty common challenge, right? So if you want to know when a VI gets run as a reentrant VI and maybe what nugget of information was flying through it, you can make a named queue, for instance. And if that named queue exists, then go ahead and then push a value into that queue. And all you need is two nodes on a diagram: obtain queue and in queue element. And well, I suppose if you want to release the queue, because if it was made or whatever else. But what I'm trying to get at is some of these techniques where you can extract information at runtime without necessarily needing to have like that VI open in front of you with a probe on the wire and things of that nature. And so it's the creativity of the person doing the programming. Yeah. Now they need certain individual techniques and tactics to facilitate that. Another simple one for like a level 1 dev is custom probes. This is an instance where you do have the code open in front of you, but custom probes are so underrated in terms of their value. People know that they're there, but most of the time people are like, yeah, I knew it was there. I kind of do a thing. But man, if you've got digital data flowing through, you want to know what it is, great. make a graph for that digital data, or transform that digital data into the payload, or do something else with it. Especially in the world of RF, I work with complex data sets all the time. IQ data. People are like, what is IQ data? It's complex data. It's a multidimensional information across an array. And usually the data is not stored. You can't tell anything about the data by seeing an individual trace of I and Q, or the individual dimensions. You want to see power versus time, frequency versus time, the spectrum, the constellation, other things about that. And there's this whole suite of custom probes that we've made for RF that is like my bread and butter for debugging. And I think if more people open up their creativity towards that, as like I said, wherever you are in the LabVIEW scheme, if you're an architect, great, give somebody custom probes for your thing, right? In the name of replay, how easy would it be if you dropped a custom probe on, say, a mother cluster, and it just logged that mother cluster over X number of iterations for the purpose of getting that as a dump out, and for the sake of reconstituting or effectively rehydrating an individual module with that core piece of information to replay out what happened over X period of time, to try to facilitate that. It's very simple. You doesn't have to be part of even the framework. You just drop the probe, it gets the information. Great. Now you move forward from there.
That could be great for like a queue-driven thing, right? Because you can just capture everything that's in the queue, and then you just iterate through it.
Yeah. All of our message handlers out there, it's message plus state data, if you will. And then it does what it does. There's nothing else in most circumstances going on in your system. So why don't we provide that for ourselves, right? That's just one of these.
Yeah, I have not played around with the custom probes too much. I'm one of those people who kind of knows about the position. But what I do use them for a lot, and I don't know if these cast custom probes, but the ones where like you can like set it to a breakpoint if something happens, those are like super useful.
That is
like really useful for debugging.
Yeah, breakpoint. Well, it's not breakpoint. It's start execution highlighting.
There's a toggle one too. Yeah, you can just breakpoint, or you can toggle.
Or the conditional ones.
Yeah,
but So when do we deal with more data than simple scalars? Very often. And when is there more information that we could do? Because to some degree, even you could take multiple data sources from within your code, bundle it, if only for the sake of that instance, and make a custom probe for that new effective collection of different nuggets of information. And underneath normal operation, it doesn't get used. But when you want to debug your own code, now you've got a single wire that you go right there. And there's all of your information, and it's crafted in a way that you want. You can make a probe that has tabs that shows data in different ways, or kind of gives other insight. Or another one, when you're dealing with instruments, this is a huge one, where if you probe a reference to an instrument, be it Visa or some device, some NI device or whatever, you've got access. There's a live reference in that probe to do something with. You could extract all of the information from your device when that probe gets hit. You want to know what a coerced value of input scaling range was. Great. You don't have to change your code. You can just make a custom probe to exist, perform whatever action that you wanted to, never modifying your code shy of a probe, and then delete the probe on the other side. Right? It's just a massive debugging tactic to leverage that. Once again, it's if you're never exposed to maybe some of these other ways of thinking about it, you kind of never get there.
Yeah. So where do you think people learn these? Are these debug tools taught anywhere, or is this just learned from trial and error and experience?
I know for me, my wizardry and Sherlock Holmesery has just been trial and error, and I think that's kind of when I talk about the democratization of debugging. I want more of the world to hear this, to recognize this, and for us as developers to be putting more things in there, because I would love for to just go to a SAS workshop and just make a 5-part lecture on here's the things for debugging. Even for my presentation, as I'm putting together the slides still for 48 hours from now, I'm seeing, man, I could talk. There's so much to talk about, and there's so much that the world needs to know. And there's no real home I could ideally what I want this presentation to turn into is I really want to light a fire in the world where people are like, hell yeah, let's do this thing, and start putting ideas so that there can be a home for common debug techniques for certain scenarios, common debugging design practices that facilitate other things, custom probes, right? Just all of these things where it is part of that learning process and procedure, right? I looked at HSE Humplesoft's website. It's like they've got this whole tree on the left hand side that showcases all the things that they do and all the ways that they teach people and the dearth of information that they let be out public to the world. And there should be a directory in there that maybe the world could point to say, like, hey, that's where we need to go to like really start learning how to be not only a good debugger ourselves, but also a good steward of people debugging downstream.
Yeah. So you're also very well known for your TLB or top level baseline. What debugging tools does that have built into it?
Yeah, no, that's so TLB Prime, or actually TLB Prime 2.0 was a different incarnation. And for those of you listening, TLB before DQMH existed, before the JKI state machine existed, there was a queued message handler. It's maybe after like the VI Tech one, but or VI Engineering, either one. That basically was birthed from my time at Texas Instruments, and it was just a common queued message handler that I referred to as top level baseline. It was just this queued message handler that was, from the get go, from the instantiation of the template, you had a program that ran, and you could even build it into an executable, and it took into consideration all the things, right? Even changing out the layout of the front panel was just very simple, but it didn't do anything inherently. It was just the good starting point. And Top Level Baseline Prime was a revision of that actually took the concept of a queued message handler and mated with it a state machine. And rather than get into that, the 2.0 version of that, I added a bunch. Actually, with the help of Aaron Ryan, another NI employee, where inside the mother cluster, which we had now turned into a class, we included, actually, this is Mark Yednak's also a brainchild as well, where we included, as you're doing a series of actions, all right, it's kind of a bulk upload to the queue at a time. And if you bulk upload or bulk put into the queue and queued specific actions to be performed or messages in the common parlance, you would end up with, you do X number of them, one of them would error, and then there would be other things left to be done. And if something errored in that entire process, let's say you were trying to connect, you had 5 messages and the third one was, or 2 of them were connected, initialize specific hardware, right? And what would end up happening is we'd get to that point, an error would happen, and some of the hardware would be initialized and some of the hardware wouldn't be initialized. And you just get an error that one of the initialized failed. And it really wouldn't give you a lot of insight. And so inside TLB Prime 2.0 was a strategy where when an error happens, you are given the opportunity to move to a portion of the program which is safe, and you're given the insights. What happened so far? Which thing caused the error? What's the error? What's left to be done? And what's the actual state of the program? And that is just a massive amount of information for somebody trying to actually handle an error. Not even debug, but if you're trying to, by default, it just blasts open a dialog that says, hey, here's, in a well-formatted way, here's where it happened in that list of things I just mentioned. And then on the other side of it, if you wanted to actually handle that error instead of just blasting all that information out, now when an error like that happens, you can gracefully handle it, because not only do you know what the error was, but what led up to that error. And another thing that was in there was I did put custom probes in there, where in the mother cluster I included the trigger queue and the action queue, which it's just basically the 2 different message queues, if you want to put it that way. But the queues are available in the mother cluster as reference. And so when I probe that mother cluster, I get what's the state, what's the actual state data, and what are the actions currently queued up, and what are the triggers currently queued up. And it keeps a running history of, like, by default, 20 of those things. And so when something goes wrong, I can just, if I can, it's like you only know what goes wrong until it goes wrong. But if I can get to that and kind of reproduce that error, I can, of course, probe a priori, run it, and then when the error happens, I can basically reverse engineer back what led up to that, be it in terms of triggers, actions, state, and be it flow control or specific bad values.
Very cool. Yeah. That's good.
It's that one. Yeah, I'm fine if it's one developer in Korea seems to be really hot to trot about the TLB Prime 2.0. Well, the rest of the world has moved on to Actor Framework and everything else, but or of course DQMH. But that I don't care if the world uses it now or not at this point. I think even the idea of using the prime paradigm, where you add a state machine to your queued message handler in adjunct to it, I'm even backing away from that. If I could just get the world to be more kind and more deliberate about trying to take care of either future self or future person by investing in that design for debug concept.
Very cool. All right. So one question I like to ask people is, tell me about an experiment that you tried and it didn't turn out the way you thought, and what did you learn?
Yeah. This goes back all the way to my first job out of college. And my experiment was basically one of my magnum opus, if you will, for that job that I had. And it was to recreate a program that was in Visual Basic, but use LabVIEW because the company wanted it to go cross-platform. They wanted it to go to Mac, or they wanted to go, it was already working on Windows systems. And so my manager said, hey, can you do this? I'm like, sure, I guess I can get that going. And I spent so much time trying to reproduce all this cool stuff that was in this Visual Basic program, toolbar up top and multi-window IDE where it had it, because it was basically for looking at gel fluorescences in a dark room where, you're trying to get, you see DNA. It's just all these little horizontal lines in columns on a page. And basically that's just, whatever culture emitting radiation that these 4-minute exposures do. So there's a lot of imaging, there's annotation that needs to happen on top of it, a lot of picture control stuff. But I spent all this time making this thing, and it worked. And it worked well, and it had certain design principles in it, but it was still early in my career. And I had left that company. I eventually went to work for TI. And when I eventually ran into somebody from that company, I'm like, oh, hey, Daddy, how's it going? And basically their statement was, we didn't use it. And I'm like, what happened? This was the thing. It gave you all the things you wanted. And what ended up happening is they said nobody could understand it.
Oh.
And it was so complicated. And so we just found that other developer that made the VB thing, and we made him make whatever updates that we wanted to do, whatever it was. And so they're like, if you want the code, you can have it, because we never touched it. And that was, talk about a learning experience. When I think about SMoRES as a concept that my mentor Tim Jones bequeathed down to me, because maybe you can only do bequeath if they're passed on, I guess. So he's still alive. He's still doing his thing. But I'm now the prophet of SMoRES, and it really highlighted that need for the S on the end of SMoRES, where you figure out what you could do, and then you have to evaluate reality for who's going to own your thing on the other side of it. And that need to give good credence towards us. You may need to do things simpler than what you want to. Right? You might, every time you make something more scalable, modular, reusable, and extensible, it adds a layer of complexity. Ideally to good effect, but not for everybody. Right? Even using OO, right? Using it in LabVIEW, right? It's certain levels of abstraction and certain levels of good flexibility just set people on their heels. And unless you're going to devote your time to making sure they can come up to speed on it, if you don't have time to do that, or you don't provide the collateral to enable them, don't get your code thrown away, right? It's everybody just wasted a whole mess of time there. That company wasted it. I mean, I loved it. I learned a heck of a lot about the picture control and doing so many different things. But at the end of it, that was a real tough lesson. Luckily it happened, years later. I didn't lose my job over it or anything, but it's don't start out with simple, but that other aspect of be really, really conscientious of who's going to need to, it kind of goes back to that same point originally. You have to be conscientious of who's going to step up to your code after you. And in this case, it just happened to be I was too clever for my own good and just unaware.
Well, I mean, they call it writing a code, right? So if you're writing a novel or something, you got to have your audience in mind.
That's a really good point. I never thought about it that way. I like that a lot.
Yeah. So, I mean, you could write a physics book. You could write a different physics book if you're writing it for kindergartners or high school kids or college kids, right? And so...
Well, I'm listening to Richard Feynman actually while I was driving in here. And there's the Feynman technique, start off by describing it like you're talking to a 5-year-old in terms of some given concept for what it is, right? I try to do that with RF all the time. I always say, babies to bookkeepers, I'll teach RF. But that idea of, if somebody's, well, especially if you're just not trying to describe it to somebody, but if somebody has to take care of it and love it.
Yeah, they need more details too.
Yeah, seriously.
Yeah. Yes, it's not just the audience, it's what they're going to do with it.
Yeah, and I think that's another part of it too when we think about designing for debug. There's also this other part of like, oh, well, the code's stable and I've used all my unit tests or my test-driven design and everything's great. That's fine, but somebody else is going to cause problems to your code downstream. That it might be you and it might be somebody else. That, what are you doing? What kind of success are you setting them up for, or what kind of failure are you possibly setting them up for maybe how fragile it is, or if that's the idea of if you're going to take extra time to. It's kind of like mortgage insurance.
Yeah.
When you do design for debug, you're doing mortgage insurance because you're spending extra time as a cost, but you're reducing the interest and the risk.
Yeah.
And you have to apply that appropriately based on what you know. Hey, this is going to be a fine part of the program. Or, oh, I already ran into 5 problems debugging this during development. I should probably try to make it easier for the next person downstream for when that happens.
Yeah. The other thing that just popped into my head too is debugging your processes as well. For example, like CI/CD servers, debugging is really useful there. Like one of the habits I've gotten into is like always turning on the build log.
Okay.
So that like if I have a problem and it doesn't build, I can just go and look at the build log without even opening up the machine, right? It's like upload to the CI server and I just say click open and then I just search for error and it says error, this BI not found. You're like, hey, that's really easy.
That's great. That's such a beautiful. I mean, when we see examples like that, because I mean, we're not just programmers. We use other things in life.
Yeah.
Like I said, my aha moment was using this KVM effective tool, and I'm like, I like that. I should start doing that. And in fact, in RFMX, one of our cornerstone of our RF processing software at NI, I was one of the key architects on the underpinnings of it, and I remember putting that like a flag in that basically had different error debug levels, and I was just so excited. And unfortunately it got never leveraged for a variety of different unfortunate reasons, but that was such a key moment. I'm like, I get to do that thing that made my life easier in somebody else's code, and so hopefully it's good for somebody else.
Yeah. Well, another one where I did that recently is we had one where they have config files and like people fat finger them and stuff. And so like building into your program that like if you fat finger it, you just rename it, and then when next time you launch the program, it recreates it. So then you can like do diffs and stuff.
Yes.
And see what changed. Yeah. That's really useful.
That's another aspect of design for debug too, in terms of if you're going to facilitate dumps of information, then it like a higher level implementation, like the level 1, level 2, level 3, like a level 3 implementation for debug dumps of like, here's everything, is the ability to do a diff.
Make them structured somehow so they all look the same, and then the only thing that changes is the values, and you just diff it.
Exactly. Just text, there's so many text differs out there, right? The world now is standard. That's the flaw of diffing in LabVIEW, is we don't have a pretty text file to compare.
But Git does that really easily. You just throw in your Git directory.
There's the line, there's
already
the thing,
built in,
go for that. But for us, if we're going to facilitate that, then the thing, because what's it like if you get a Windows dump, right? You get blue screen of death, there's everything, right? You don't know what it should look like normally. You don't. It's like, you got to be a wizard, a double wizard to look through one of those blue screen of death crash logs to figure out what went wrong. And but if you know what it was supposed to be versus not, then you can kind of get right to that problem. That's an example of an accelerator. The debug dump is the insight. The tool that allows you to leverage that debug dump in an efficient way, that's the accelerator. You still got to fix the bug and figure out how to fix it, but you got to it fast.
Yeah, no, that's really cool. It's a good tool. All right, well, it's been a great talk, Norm. We could keep going forever, but I think the podcast guests would appreciate it, or podcast listeners would appreciate if we kept it short.
You say that, but I am one of your listeners. I will tell you, I get to the end of my 30 minutes and I am just eager for more. I'm like, go longer. We don't have to do it now because you got your schedule.
You're the second person to tell me that. Chris Farmer always says I should go longer too.
Yeah.
So
I listen to Lex Friedman for, what does he do, 2.5, 3 hours?
Yeah.
No problem.
I
Always
listen
engaging
to a couple
the entire
podcasts that are 2 hours long too.
The world needs both. Let's just put it that way. And I think the world needs both from Sam. So, I mean, you've got your time, and maybe if you get some more sponsors out there, and I'll see if I can pump you up to try to make sure, because this is getting out to the world. Every time I see it, I wish I was more judicious to post it on LinkedIn every time one came out, but it's worth it.
Well, we'll give you some cool stickers to pass out.
Absolutely. Cool, I'll put it on my badge. I don't know if I'm going to do the full flag this year, but
okay, cool. Very good. All right, thank you.
Absolutely. You're welcome. This has been a pleasure.
Would you like to sponsor an episode of the LabVIEW Experiment podcast? Drop us a line at hello@thelabviewexperiment.com.
That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at the LV Experiment.